and go. Like and subscribe. Here we go, simplifying and rewriting trig expressions. Okay, so first of all, with this video, you definitely want to have the notes from last time, the 5.1 trig identities, the skill refresher, that thing where we were kind of comparing the algebra and the trig comparison. Okay, so we want to have all those and be relatively comfortable with it. Okay, understand that I know that we're still learning this, but as we're still learning it, we definitely want to have this handy so we can reference some of these properties that we learned and try to apply them to simplify trig expressions. Okay, so simplifying trig expressions, right? So trig identities are used to simplify trig expressions, verify more complex identities, and solve trig equations. So here are the kind of rules to simplify trig expressions. Now, essentially, we're going to be given kind of a complicated expression, and we're going to try to make it as simple as possible, right? So we're, maybe it's a bunch of sines and cosines, and we want to kind of combine those, or, a bunch of different things. We just want it to look nice and neat, condense it as much as possible. So some of the rules, some tips to simplify trig expressions. The first one, okay, we want to substitute as many sine and cosines as possible using the trig identities given. So we want things in sine and cosine. Okay, if they're not already in sine and cosine terms, we want to make them, right? So for example, cosecant, right? We want to go ahead and change that to 1 over sine or something like that, so we can actually have it nice and consistent. So that's the first one. Second, factor if possible. Okay, if you notice something that is factorable, then we want to factor. We want to maybe undistribute, right, or finding the greatest common factor, or we want to, factor the trinomial, different things like that. We want to factor if we can. We want to combine fractions. Okay, so we need to find, in order to combine fractions, right, if we're adding, we're going to have to find the common denominator, right? If we're multiplying, then it's a little bit more simple, right? You just multiply straight across. And then we want to eliminate those fractions once we combine them. Okay, so we'll see some examples like that, but I know that's kind of a weird thing to have back to back. But first we combine it, and then maybe after we see, oh, look, it kind of simplifies down because of a factor that the numerator and the denominator have in common. Things like that. So I just threw out a ton of terms at you, but just in general, okay, with this unit, again, this is a unit that takes practice. Okay, this is not one of those units where you're just gonna try to come in the last day and just do well on the test. So just keep that in mind. I mean, it's not an easy unit, but this is a longer unit for us, and it just takes practice. This is not something you wake up one day and you're just like, oh, I'm a genius at simplifying and rewriting trig expressions. No, this is something that takes time, okay, time and effort. But eventually, if you put enough time and effort into it, you should be okay. All right, so it's just I didn't wake up one day and just know how to do this, right? It takes time. All right, so you have to put in that time in order to actually do well with this unit. Okay, and then the other thing I'll say about it is this: be very careful with the operations. Order of operations will sometimes mess with you a little bit, and then also just be very careful with fractions. Okay, when we do see fractions here, be extremely cautious, okay, because I personally think that's where people will get messed up with finding that common denominator. Sometimes that's a hard part, or combining fractions. And then just be also careful with canceling. We'll cancel a lot here. We'll try to factor various different things out. And sometimes people will jump to conclusions and try to factor things that you're actually not able to factor, okay? Those are my tips and advice moving forward in this unit. Let's go ahead and begin. We'll see. As we go on, we'll start to kind of see some of the things that I was referring to in this little introduction statement. So let's do it. Work one step at a time. Work down on your paper. That's another good piece of advice there. Okay? Let's get rid of these in the back so it's not as crazy. Okay? Well, we're going to work these one at a time. So here we go. We're going to do 6 examples. Depending on how long it goes, we may split this into 2 videos. But let's go ahead and start, and then let's zoom in so we can really get a good idea of what we're looking at. Okay, so I have this long, complicated expression. Okay, I've got sine of x times cosine squared of x minus sine of x. Okay, so when I see something like this, the first thing I'm going to notice is that I've got a subtraction symbol in here. So I have two different terms. I have a term here, and then I have a term here. Okay, so if I'm going down in my steps, right, substitute as many sine and cosines as possible. Well, that's all I have. I only have sines and cosines, so no worries there. Factor if possible. Okay, so can we factor here? That's a question we want to ask ourselves. And again, I noticed, right, when I'm personally looking at this, I see that I have two different terms. They're separated by the minus sign. And I also see that I have a sine of x here and a sine of x here in both of my terms. So I'm actually going to factor out that sine of x. I'm going to go ahead and, do the factoring with the greatest common factor and pull out that sine of x. So here we go. Sine of x. Okay, I'm still left with two terms, right? I pull out the sine of x, and I'm left with cosine squared of x, and then I'm left with minus 1. Okay, and here's what I'm going to go ahead and say. When we are doing this, it's helpful. It's not necessary, but it's helpful if you write down the step that we just did. So from here to here, we factored out a GCF, greatest common factor, right? My greatest common factor here between this term and this term was sine of x, and I factored it out. So now I'm left with something like this, sine of x times cosine squared of x minus 1. Now, we're still learning this, all right? But the goal here is to trick your brain, and when you see things like, when you see some 1s and cosine squareds, or if you see some 1s and sine squareds, and you see some sine squareds and cosine squareds and 1s and all those three things, or if you see even, with tangent squares and secant squares and cotangent squares, cosecant squares, I threw out a lot of terms again there, but when you see that, your brain, you want to trick your brain into saying, okay, maybe it's a Pythagorean identity, which we went through in the notes last time. And this particular one, that's a Pythagorean identity. Now, maybe you didn't know that, but that's okay. All right, again, when you see cosine squares or sine squares or 1s, you want to say, okay, let's at least look and see if we can replace that with a Pythagorean identity. So we're looking at my Pythagorean identities, okay, and we got my original sine squared of theta or x plus cosine squared of theta or x is equal to 1, right? And then I see here I've got the cosine squared of x minus 1. So we just got to find that one, and here it is, cosine squared of theta or x minus 1. So instead of this here, I can replace it, because these are equal, with negative sine squared of x, right? And that's a whole lot more simple than cosine squared of x minus 1. So instead of that, I'm going to go ahead, right, I've got my sine of x here, that doesn't change. And then in the parentheses, though, I can replace it with negative sine squared of x, okay? And that was the Pythagorean identity, okay? So again, not necessarily to write these steps, but it is helpful if you can really see, especially when, we're going to do a lot of these, like straight up, we're going to do a lot of these. And if you can, write something to trace your steps, it usually is a good thing, okay? So, because a lot of times it'll look like total gibberish. Maybe you're like, okay, I see how we got from here to here, but like I can't remember, right? Or I know I did it earlier, but now I can't quite see it again. So it's good to write it down, okay? Cool. It's kind of like your proofs. Like, this is the reason why, right? Like, the reason we can go from here to here is because we factored the GCF. The reason we can go here to here is because of that's a Pythagorean identity. Replacing this with this is a Pythagorean identity. Okay, and so now we just multiply, right? We've got sine x times sine squared of x, but then we've got that negative. So out front, we put the negative, but this is sine cubed, sine of x cubed. Okay? And that's a whole lot more simple than all that stuff in there. So that is our first simplifying of a trig expression. Okay, so we know that this and this are the same. Okay, because we just did some factoring and replacement with a Pythagorean identity. All right, and again, I'm going to try to explain as much as I can with like how I know to go from here to here. That is one of the hardest parts, right? Like maybe you see why like all this is true, but maybe when you're doing it on your own, you're confused as to where to go. Okay, but again, I'm going to try to give you some tricks to kind of start somewhere, okay? Because a lot of times that is the difficult part. But quickly on this one, right, I noticed that there was a sign here and a sign here, so I'm going to factor that out. And then I see that I have, again, my brain is like, okay, when I see cosine squared or sine squared or 1, I just jump to the Pythagorean identities, and honestly, like, I just know this, right? Like, well, truth is I don't actually, like, know these because of the way we have this course set up, because I'm giving you these, right? You're going to be able to have these handy in order to use. So, but just finding and identifying which ones matches, right? And this one definitely matches with this, so I can replace it, okay? Cool, there's our first one. All right, let's go ahead and go to the next one, okay? And I have plenty of space. Like I may have too much space, but I personally, these are a lot shorter on the notes that you'll see in Google Classroom, but I'm rolling with this, okay? Just so it's nice and spread out. I don't like to be constricted with my space. Okay, on this one, I notice immediately I've got a fraction, okay? And I want to combine, I want to actually do this operation here, right? It's telling me to add between this fraction and this one, and in order to do it, okay, just with all of our fractions, we've got to have a common denominator. So let's get a common denominator. Well, in this particular one, this and this don't have any common factors, so we're just going to multiply them. Okay, so the common denominator, if you wanted to, maybe that's a good idea. So common denominator. Okay, you can write out the common denominator, right? It's 1 plus cosine of theta times sine of theta. So that's what I want on the bottom for both of my fractions, right? So I'm going to change this fraction. I'm going to change the way it looks. Okay, it's going to be the same fraction. It's just a different writing of it. And then same with this one. And once I get that common denominator, then we can actually add those two things and perform the operation that's telling us to do, right? Because this is telling us to add these two. Well, we can't really. Come on. There we go. Okay, it's telling us to add these two. I didn't like that yellow shade anyways. But it's telling us to add them, so that's what we're going to do with the common denominator. So let's go ahead and begin. All right, I've got the 1 plus cosine of theta already on this one, so I need to introduce the sine of theta on the top and the bottom. So we've got sine of theta, okay, all over 1 plus cosine of theta. And again, the one we want to introduce is the sine of theta. So I'm going to go ahead and write sine of theta here, and then sine of theta on the top. Now, again, the reason I can do that is because it's a fancy version of 1, right? Sine of theta over sine of theta is 1. Right? Anything over itself is 1. So I'm multiplying this fancy version of 1 to be able to get a common denominator. Okay? So I've got this, in other words, this fraction right here, this entire one, and this are the exact same value. It's just written differently. Okay? So there's that. Okay? And then plus, same thing here. I want the same denominator. So personally, when I write it, I kind of want to just write the fraction first, the one that I see. Okay, cosine of theta over sine of theta. Cool. Okay, and then I've got, I want to introduce this part here, right? The 1 plus cosine of theta, because that's the part that I don't have. So 1 plus cosine of theta here. I'm not going to change the fraction. I'm just changing the way it looks because I'm going to put it on the top and the bottom. Again, fancy version of 1. Okay, so now I have changed the way my fractions look. Let's go ahead and start to simplify some of the pieces on the top. Okay, so on the top, okay, I can just multiply these two. So I'm going to go ahead and do that. Okay, sine squared of theta. Okay, and you know what? The second I see that, maybe this is going to involve a Pythagorean identity because I've got that sine squared. Okay, that's just a good thing to start noticing. Okay, so 1 plus cosine of theta, sine of theta. All right, and all I did is just rewrote the, sine times sine. That's all I did, right? Sine times sine of theta is sine squared of theta. Okay, up top over here, I've got cosine of theta, right, this, times these two. So I've got two terms here, so I can distribute, right, distribute. Okay, so we'll go ahead and do that. This cosine of theta here, and then plus cosine times cosine. So that's going to be cosine squared of theta, all over 1 plus cosine of theta, and then times sine of theta. Now, so far all we've done is just simplified what, we factor, or not factored, but multiplied, right? We multiplied sine times sine, and then we distributed that cosine. So if you want to write that, you can. That's not typically one I would write, but we multiplied and distributed. Okay? From this step to this step. Now, let me say this. Some people will do these things in very different orders, okay? And that's perfectly okay, right? Like as long as we kind of arrive to the same spot, that's all right, okay? So, and there's levels to this, right? Like this is not a, you got it or you didn't sort of thing. This is a, can you work your way towards simplifying these trig expressions, right? This is, it's not a binary thing, if you will, right? It's not a right or wrong. This is a process where, theoretically, right, the test I would be grading like partial credit big time, okay? But yeah, just something to keep in mind. And everyone's going to do these things differently, right? Like some people might do it in a different order, just something to consider, okay? Now, me personally, maybe some people try to multiply that sine here to here. That's not necessarily wrong. You could absolutely do that. I just choose not to. Okay, I like to keep my factors just in case we end up canceling them out. Okay, the reason why I like to keep them is because usually you do end up canceling them. Okay, so something to consider. Okay, now we can actually add now, right? We can actually add because we have the same denominator. Okay, so let's go ahead and combine these two. Okay, so 1 cosine of theta. I like to start with my denominator. Okay, you can put parentheses there if you want. All over. Okay, sine squared theta plus cosine of theta plus cosine squared of theta. Okay, there we go. So all we did here is just we added the two fractions. Okay, add fractions. I don't know, something to keep track of what we've done. Okay, and then the next step I see. Okay, again, we're trying to train our brains to see this, but sine squared and cosine squared. Now, we're not there yet. Okay, maybe you didn't notice that. Okay, but we want to see, all my sine squareds, my cosine squareds, my tangent squareds and secant squareds, all that stuff, right? All the Pythagorean identities. We want to see those and at least test them out, right? We want to see what we can find with all these and see if we can replace them. So on this particular one, this is really the most basic one: sine squared of theta plus cosine squared of theta. So that is what we're going to replace, right? So here it is, right? Sine squared of theta plus cosine squared of theta is equal to 1. That's my Pythagorean identity. Let's go ahead and use it, right? So this plus this is equal to 1. So I now have 1 and then plus the rest, right? So like this kind of stays up here, right? So we don't touch that one right now. Okay, so we got 1 plus cosine of theta. Okay, and then all over 1 plus cosine of theta, and then times sine of theta. Okay, here's what I noticed on this next one. Let's go ahead and write it. It was a Pythagorean identity. Okay, Pythagorean identity. Cool. Here's what I noticed on this next one. Look at this. I've got 1 plus cosine of theta on the top, and I've got a factor of 1 plus cosine of theta on the bottom. Now, what I mean by a factor, right? What am I doing here? I'm multiplying, right? I'm multiplying in between with my parentheses. I'm doing that times this. But I'm also straight up multiplying on the top. Now, what I mean by multiplying, I know that's a little bit weird because we're technically adding in between the parentheses. But this whole thing, right, is just one piece, right? It's like I've got one number, right? One number times another number. So I can actually cancel this and this, okay? So, but when they cancel, right, when you have the same thing over the same thing, it's just a 1, right? It's just a 1. So I leave a 1 on the top. I could literally replace this with 1 and this with 1. And we're going to end up with 1 over sine of theta. Okay, now a lot of people will struggle with this piece, okay, because they'll just jump to conclusions. We can't just, like, for example, we can't just, I don't want to get too confusing here, but let's say it looked like this. let's say it was cosine of theta, and then it was like 2 plus cosine of theta. Okay, just completely separate side note. Some people will try to cancel these two. Okay, don't do that. Definitely don't do that, because we're not. Notice what we're doing in between here. We are adding in between. We're not multiplying, right? So this isn't a factor on the top, factor in the bottom sort of thing. Okay, so just be careful. Try to see the difference between what I was attempting to not do here, and then what I am allowed to do here. Right? So this entire thing is a factor. This entire thing is a factor. Okay. So anyways, we have 1 over sine of theta. Okay. Now some people might stop there, right? And that was a factoring. We factored that out, or factored or canceled maybe. We're so used to saying canceled. Okay. So we have 1 over sine of theta. Now, if you want to stop there, I mean, it's probably perfectly okay with me. Probably perfectly okay with most people. But typically, we don't want to leave something on the bottom like that, right? I know we say that we want everything in sine and cosine, but in this particular one, when you're just left with 1 over sine of theta, like I said, maybe you can stop there. But we know what 1 over sine of theta is, and that is cosecant, right? So that's cosecant of theta. So really, that's a more simplified version of this, because we don't want the reciprocals. Okay. But essentially, what we did here is we did use the reciprocal identity. So if you notice, right, 1 over sine of theta, that is 1 over sine of theta. That's this right here. So this is equal to cosecant. If you want, it's a good time to write reciprocal. That was what we used here, right? The reciprocal identities. That is that back page of last lesson. All right. Let's see. Got some more time. So here we go. Let's do another one. And again, I'm trying to explain these as detailed as possible. I'm trying to give you an idea of what I see when I approach these. Okay. On this one right here, sine of x plus cotangent of x times cosine. Sorry, not cosecant. So be very careful with these, right? Look how similar these are, right? Literally the difference between a t and an s. So make sure you are clear about what you're looking at, right? This is a cotangent. Okay, this is a cotangent. All right. This is definitely one of those problems where we want to follow those steps up top on that first page. So we want to go ahead and substitute as many sines and cosines as possible, given the identities given. I got a sine here. I don't have a sine or a cosine here, and I have a cosine here. Okay? So we want to rewrite that cotangent. That's going to be our first step. So I see cotangent, get rid of it. Okay? Let's get things in sine and cosine, because we can work with sine and cosine. Okay? So I've got sine of x. I don't change that one. But I know cotangent. Right? Hopefully we remember that, definitely no tangent, right? Tangent is sine over cosine. Hopefully we remember a little bit from last time that we learned cotangent, right? Cotangent of theta is equal to cosine over sine, right? Again, tangent, sine over cosine, cotangent is flipped, okay? So cosine over sine. So cosine, we're working with x. Sometimes you do theta, sometimes you do x. But cosine over sine. Okay, we got this. So we replaced cotangent with that, and then we've got times cosine x. Okay, so all we did is we did the quotient identities. Okay, this is a quotient identity. All right, is what we applied there. Okay, so let's see what we have now when we multiply it. Okay, right? We can now multiply this to this. So we now have sine of x still. I'm just going to bring that down. Okay, plus. I have cosine. I'll keep wanting to say cosecant. I don't know why. Cosine squared, right? Cosine times cosine. We just multiply straight across. If you really wanted to rewrite, you could write it as cosine of x over 1. So cosine squared of x over sine of x. Okay, and we are adding in between here. Now, what we should notice is now we're trying to add with fractions, right? We have this and we have this. Okay, and we just multiplied. Right? Okay, but we're trying to add fractions, right? We have this here and this here, so we need to get a common denominator. Okay, well, in order to get a common denominator, the denominator over here is sine of x. So I could just introduce sine of x over here on the bottom. Okay, and if you wanted to write the common denominator, right? The common denominator is sine of x. Okay, but with sine of x, I need a sine of x on bottom, right? On that denominator there. So with this. right? I'm going to multiply the top and the bottom by, and if that helps, right, always write it as, sine of x over 1, right? There you can really see that you don't have the common, or a common denominator. Okay, so I need a sine of x on the bottom, but in order to do that, I'll multiply the top and the bottom. So here we go. We've got sine of x times sine of x, okay, and then we put a sine of x on the bottom as well. And then on top, we've got cosine of x over sine of x. Nothing changes there, right? Nothing changes on this right fraction. And, right, and we notice, right, if we were to cancel those, we would just be left with what we had. So we're introducing it on the top and the bottom, okay? So what we did here is we just found a common denominator, right? Common denominator there. Okay, now that we have a common denominator, we can simplify it. So if you notice, right, I've got sine of x times sine of x. So if you wanted to multiply these out, that'd be a good call. Okay, on top we have sine squared of x over sine of x, and then we have plus cosine squared of x over sine of x. Okay, and then we should notice, right, I mean, sine squared, cosine squared, so maybe it's a Pythagorean identity sort of thing. But first, from here to here, let's go ahead and just add, right? Because we can now add because we have the same denominator, right? The same denominator. So let's go ahead and do that. Sine of x, or sine squared of x, plus cosine squared of x, all over sine of x. Okay? From here, we should see, right, that that's your classic Pythagorean identity. Okay? And all we did here was we added, right, from here to here. All right, on this next one again, sine squared. We see those, we see sine squared, we see cosine squared. Let's try to apply our Pythagorean identities. We should trick our brains into identifying that, oh, we're probably going to use a Pythagorean identity here anytime I have sine squared and cosine squared, or a 1 with cosine or sine. Okay? So there it is. This is equal to 1. Again, that's that really the most basic Pythagorean identity, right? So sine squared plus cosine squared is equal to 1. That's what we have here and here. Again, definitely want to keep this handy, right? Like, this sheet is crucial, okay? This sheet is crucial. You've got to understand all this in order to really move forward with this. So this is all just 1, okay? So 1 over sine of x. And we end up with literally the exact same thing as we did last time, right? So here we applied the Pythagorean identity. We could theoretically stop there. Some people might frown. I don't know. It really depends. I'm okay with that, me personally. But I guess technically it's not as simplified as it could get because we don't really want things on the bottom. We want to just have the, one piece as opposed to, one piece here and then one piece here. So this is going to be your cosecant of x. What we applied there was one of those reciprocal identities. Okay, one of the reciprocal identities. Sweet. I'm going to go ahead and stop there. Got class soon. So we will do 3 more in part 2. That will be part 1. See ya.